Welcome everyone in lecture number 10 of Laplace transform. Here in this lecture we will learn how to find Laplace transform of integrals. Let us see what is this concept of Laplace transform of integrals. If Laplace transform of the function ft is fp, I always denote the Laplace transform of the function by fp. Then Laplace transform of 0 to t fx dx. This is an integral from 0 to t fx dx. Its Laplace transform is defined as Laplace transform of ft divided by p. It can also be written as fp divided by p. So whenever you have the Laplace transform of integrals, the integral is converted into division by p and L is operated on this fx. That will become Laplace of ft. You can also use x here, but since we use the function ft always, so we use ft here. So since Laplace of ft is fp, so this is fp divided by p. For example, evaluate Laplace of integral 0 to t sine x divided by x dx. So we solve this. This is treated as fx. What is given to us as fx? This is whole as fx. So here fx is given to us as sine x upon x. Okay. That means we have to find here Laplace transform of sine t by t. So this implies ft. If we write the value of ft here, it is sine t divided by t. So if you look at here, you have to find the Laplace of ft. So we have to find, so first we have to find Laplace of ft. That is equal to Laplace of sine t divided by t. We know that Laplace of ft by t is defined as integral p to infinity fp dp, where fp is Laplace of ft, right? So this is equal to integral p to infinity Laplace of sine t, that is 1 upon 1 plus p square dp, that is equal to tan inverse p. We apply the limit from p to infinity, and as I have done earlier, the value of this expression comes out to be cot inverse p. I am not doing it in the details. Okay, you can go through my previous lectures for the evaluation of this expression. This is equal to cot inverse P. So we have the value of Laplace of ft, so that we now write the value of Laplace of this expression. This implies Laplace of integration from 0 to t sin x divided by x dx, which is defined as Laplace of ft by p, Laplace of ft by p, and Laplace of ft is cot inverse p divided by p. This is the answer. Example number 2. Evaluate Laplace transform of integral from 0 to t e to the power t sin t divided by t dt. So here, if you compare this expression with this expression, the value of fx is this whole expression, e to the power x sin x divided by x. So ft is actually given here in the form of t, parameter t. So it is not always assured that the function is given in the form of parameter x or variable x. It may also given in some other variables. So you should write the value of ft always. Okay. The value of ft is this. So here we have to find. So we have to find Laplace transform of ft. That is Laplace transform of e to the power t sin t divided by t. अब इसको आप दो तरह से कर सकते हो. Let me do it on the next page. Laplace transform of e to the power t sin t divided by t. आप इसको दो तरह से कर सकते हो. या तो हम sin t डिवाइडेड बाय t को ft की तरह यूज करें. तो अगर हम ऐसा करते हैं, अगर हम sin t बाय t को ft लेते हैं, तो फिर हम कैसे मूव करेंगे? हम लाप्लास फाइंड आउट करेंगे. Laplace transform of e to the power t sine t divided by t. That means e to the power t ft वाली प्रॉपर्टी फर्स्ट शिफ्टिंग प्रॉपर्टी हम यूज करेंगे यहाँ पर. Here we use first shifting property. First shifting property by taking this as ft. Okay. Or what you can do is you can also take e to the power t sine t as ft. अगर आप ऐसा करते हो तो फिर आपको लाप्लास फाइंड करना पड़ेगा e to the power t sin t की ग्रुपिंग यहाँ पर होगी और फिर डिवाइडेड बाय t होगा. तो here you use the property of ft divided by t. That means when the function is divided by t, then how to find the Laplace transform? You have to use that property by taking this as ft. Here we are grouping these two functions sin t by t. So the property that we apply on these two is for shifting property. If we group these two together, then we take this as a whole as a function ft. Then we use the property of ft divided by t. So let me mark this as A and this procedure as B. So if we follow the procedure number A, let us take the procedure number A. So we will find Laplace transform of e to the power t sin t divided by t. By first shifting property, if you remember what is the value of this expression, this is equal to Laplace of sin t divided by t, and the answer variable p is replaced by p minus 1 because e has positive power here, which is 1. So p is replaced by p minus 1. So we solve this bracket first of all. Now we apply the property of ft divided by t here in finding the Laplace transform of sin t divided by t. So it is p to infinity into Laplace of sin t. Okay. And then this is dp here. And here we should write p should be replaced by p minus 1. We always write this so that at last we remember this change. Otherwise we'll forget to do this change. So Laplace transform of sin t is 1 upon p square plus 1 dp. Again we write here p should be replaced by p minus 1. This is equal to tan inverse p to infinity. Okay. P is replaced by p minus 1. The value of this expression is cot inverse p. We should not write it directly in the exam. We should solve it properly. This is equal to cot inverse p minus 1. Let me write it. Okay. So this is the answer of when we follow the procedure number A by taking sin t by t as ft, and we separate e to the power t. Okay. So if you follow the procedure number B, you will get the same answer. So please try it by yourself. Procedure number B. Try it yourself. You will get the same answer. So we have this question. Okay. So the answer of this question is uh, this implies Laplace transform of integral 0 to t e to the power t sine t divided by t dt is cot inverse p minus 1 whole divided by p. Okay, this is the final answer of the given question. Next example is evaluate Laplace transform of integral 0 to t e to the power minus t cos t dt. Okay, so again we write that according to definition the value of this integral will be equal to Laplace of e to the power minus t cos t, because this is ft here, whole divided by p. Okay, so we have to find Laplace transform of e to the power minus t cos t. That is very simple to find by first shifting property. This is equal to, you should write Laplace transform of e to the power minus t cos t will be equal to Laplace of cos t, and the whole answer p is replaced by p plus 1. It is p upon p square plus 1. P is replaced by p plus 1. Should mention the property which you are using here by first shifting property. P plus 1 divided by p plus 1 whole square plus 1. So Laplace of 0 to t e to the power minus t cos t dt will be equal to p plus 1 whole divided by p into p square plus 2 plus 2p. I have solved this. This is equal to this. So this is the answer. I hope you understand this method of finding the Laplace transform of integrals where the limit is from 0 to t. there is a small result based on Laplace transform, that is that is in the form of a corollary, you can say, that say that if Laplace transform of ft is fp, say, then Laplace transform of, sorry, then integral 0 to infinity ft by t can be evaluated with the help of Laplace transform, and its value is equal to integration 0 to infinity Laplace of ft dp. You can see the value of this integral is nothing but this uh, this the value of this integral is equal to integration of Laplace of ft. Means if this function is difficult to integrate, you can integrate its Laplace of only ft. Maybe it's simpler to integrate. So this value is equal to this value provided the integral exists, the value of the integral if exists. So you can see the application here in the form of an example. Uh, Suppose you want to evaluate the integral 0 to infinity sine t divided by t. You can see that it's very difficult to evaluate this integral. It's very difficult. But with the help of this formula, you can write the value of this integral as equal to same limit but Laplace of only sine t here. Okay, so this is equal to integral 0 to infinity 1 upon p squared plus 1 d. This is not dp, this is dp. So this is tan inverse p, and you know the value of this is cot. This value is pi by 2. Okay, so you can see it's very easy to evaluate this integral now with the help of this corollary, which gives you the application of Laplace transform in evaluating integrals of the form 0 to infinity type. So we'll do some more applications in the next lecture. Okay, thank you so much.